Alright, so we're going to talk about domain and range of quadratic equations, and you can see they all kind of look like parabolas here. Domain is the x values of the function. So do you guys remember to do the x values? Which way do we scan the graph? What side do we start on? Start on the left, so scan from the left to the what? Good. Alright, so when we read the domain, we're going to read from left to right. And when we read the range, we're going to start where? Yeah, so you start down at the bottom and you go up to the top. Okay? Alright, so domain, D is domain, R is range. So for the domain, for this one, I just have a set of points. If you have a set of points, the easiest way to do that is in set notation. And these fancy brackets are for set notation. And we're just going to list the x values. Okay, so what's the first x value we get to? Good, -2. This one. -1. This one. So remember, we're looking at the x value, and they didn't write it. Yeah, they left the 0 out there, but that's 0. And then 1, and then 2. Good, you guys say great. -2, -1, 0, 1, 2 in fancy brackets. Alright, we do that when it's just a set of points, when it's not filled in between the points. Alright, now we're going to do the range, and we're going to scan it from the bottom to the top. So what's the first y value we see? -3 is the y value. Good. This one? -2, and then this one is how much? 1. So notice, because some things repeated, we had fewer values in our range. So we had -3, -2, and just 1. Alright, now these other two graphs are not just points. So we're going to need to use interval notation. You can actually see, even though we haven't really used it yet, there is a word bank down here, and you can see some of these are in interval notation, which is basically just from the smallest to the largest. So for the domain, what's the smallest x value in the domain? I wasn't clear on which number you said. What's the smallest x value? So -2 is the smallest x value, and because that dot's colored in, I want to include it. So from -2, including -2, and look, it can be -1.9, -1.8, -1.7, -1.6, all of these, right? So -2 is where I started. It goes through all these negative numbers to 0, and then it's 0.1, 0.2, 0.3, 0.4, 0.5, all of these numbers until I get to what biggest number? 2, good. So my x's are all of the numbers from -2 to 2. Alright, my range starts at the bottom, so what's the smallest y value here? At the bottom of my graph? -3, good. So I'm starting at -3, and then I'm going up to the biggest y value, which is how much? 1. So the reason we don't just list the points is because it's impossible to list the points. Like, I can list -3, -2, -1, 0, and 1, but there exist points in between these two. So I have like -2.9, -2.8, -2.7. I have tons and tons of numbers in between these. So it's impossible to list them, so we just say smallest to largest. Who has a question so far? I'm going to do one more, and then you guys are going to do the ones on the bottom. Okay. Alright, this one is similar in some ways, but it has these arrows that are going to go, these arrows are going up, but they're also going to the left a little bit. So they're going up and to the left, both ways. Okay? This one's going up, and it's also going to the right a little bit. So my domain, it doesn't start right here. It starts all the way on the left. What number is all the way on the left? So -3, but I have to keep going past -3, -4, -5. What's the smallest number? It's negative infinity. Good. So at the very end of this number line is negative infinity, and that's where my domain starts. And then it keeps going to the right as well. It keeps going to the right forever and ever and ever. And what's that biggest number? Is positive infinity. Good. So at the end is positive infinity. Now, if I asked you to start walking and walk until you hit infinity, when would you be done? Never, right? You'd never be done, right? You can't get to infinity. You can't get to infinity. So I can't use a square bracket to include that point since you can't ever get there. For infinities, you always use parentheses to say, get as close as you can to infinity, but I know you're not going to really get there. You can't actually arrive at infinity. All right, range. There are no arrows pointing down. So since there's no arrows pointing down, there is a smallest number. What's the smallest number on this parabola? Negative 3 is the smallest number. So we're going to start our range at negative 3. And then you can see these arrows keep going up until, what number is at the very top? It's positive infinity up here, yep. So this range is negative 3 to positive infinity. Okay, so I'm going to pause the video for a minute, and I'm going to let you guys work on the 3 on the bottom, and I'm going to come around and answer your questions, because I know that it's tricky when we're looking at different situations here. Okay, so we're ready to go over these. This parabola has arrows on it, and the arrows are pointing both down to negative infinity, and this one also left to negative infinity. This one's going down, but also to the right to positive infinity. But there's no arrow pointing up. So for your domain, you're all the way to the left and you're all the way to the right. So did you guys write negative infinity to infinity? Some of you did? Okay. If you didn't, we're going to fix that one, okay? Because so I got negative infinity comma infinity. So this is called interval notation, and all you do is you write the smallest number to the largest number. You don't list all of the numbers in between. Just smallest to largest. I said no. The range is pointing down to negative infinity. That's the smallest number. And then my largest number is up here. What's my largest y value? It's 3, good. So my range is negative infinity to 3. All right, which of these ends is going to get a parentheses? Do I put parentheses on the 3 or on the negative infinity? Negative infinity, good, because I can't include that one. And then what do I put on the 3? The square bracket. Okay, questions? Okay, this one does not have arrows. So when I ask you what is the smallest x value, there's actually a number. Smallest x value is what number? Negative 2. And then I continue along all of the x's until I hit what largest number? 2. Okay, my range starts down here at the bottom at what smallest number? What's my smallest y value here? It is negative 1. And then it goes up to what biggest y value? 3. Andre? No. Because somebody else is ahead of you. Ahead of you. Yeah. Probably. All right. Last one, these are just individual points, so we're going to use set notation to list the individual points. So for the domain, let's list the x's. The first one is negative 2. The next one is what number? We are going to have a 2, but I'm going to just go in order from left to right. So I have negative 2 and then negative 1, right? And 0. So AB, take a look how I'm looking at just the x-axis. This one's negative 2. If I look at the x-axis, this one is negative 1. This is 0. This one is what number on the x-axis? Good. And the last one? Good. So we're listing all of the x values of the points. Okay. And then for the range, we're going to list the y values of the points. So we start down here. And our lowest y value is what number? It's -1. And then the y value for these points is how much? And then the last one? 3. And then don't forget the fancy brackets. You need everything to make your domain and range. Okay. What questions do you have before we do something different with our quadratic equations? Okay. So I'm going to turn the paper over. And on the next page, what we're going to do is we're going to use graphing to solve equations. All right, on day 1 of our unit, we named these points right here, and we called them several different names. Do you remember this on your vocabulary sheet? One of the names was x-intercepts. Who can tell us another name for these points? Zeros. Very good. So they could be called x-intercepts, or they could be called zeros. What was another name? Roots. Very good. Does anybody have the last one? Solutions. Good. So I could be asking you for the zeros, the roots, or solutions, and for any of those things, I would be looking at the x-intercept. So in number 1, it says find the zeros of the equation in vertex form. So this is an equation written in vertex form. It doesn't really matter what form it's written in to answer the question, but I was just trying to introduce you to that vocabulary term, vertex form. So the solutions are still here and here. X equals -1 and x equals 5. Good. Okay, in number 2, it says find the zeros of this equation written in standard form. This is called standard form. But the zeros are still located at the x-intercept. So what numbers am I looking at? 2 and what was the other one? 4. So x equals 2 and x equals 4. So what that means is that if I put 2 back into this equation and I put this in a calculator, it would give me the answer 0. These are the solutions that give you the answer 0. 4 does the same thing. So looking at these equations, you can see that sometimes quadratic equations have 2 solutions. Alright, the last one is written in intercept form. It's just another way to write a quadratic equation. Intercept form. We're just finding the solutions by graphing. So I graphed the first 3 for you. And so I'm finding the zeros, and one of the zeros is -4. What's the other one? 2. Good. Okay. So for the rest of this worksheet, all we have to do is decide what form it is, and then graph it on Desmos to find the zeros, the roots, the solutions, the x-intercepts. Remember, 4 names for the same thing. Okay? So you're going to do this by graphing on Desmos. To figure out what form it is, let's look and see what we have. Intercept form has how many sets of parentheses? 2 sets of parentheses. Standard form has how many sets of parentheses? None, right. And vertex form has how many sets of parentheses? 1. So that might help you figure out what form they're in. And then you're going to need to use Desmos in order to graph them and find the zeros. Remember, if you click on the 0, it's going to tell you exactly what number that is. Okay? So let's take a few minutes to do that. Okay, let's look at number 4 here. And which, Jane, what form did you put for number 4? Intercept form, very good. It has 2 sets of parentheses, just like intercept form. Alright, next one, number 5. Bryce, what did you put for number 5? I know your paper's away, but can you see it here? Vertex form, good. Vertex form has just one set of parentheses, and you can find the vertex right in it. Vertex form. Okay, Andre, what did you put for number 6? Good, also vertex form. This one has a 0 here. When I ask for solutions, often it's going to have a 0 instead of a y, but it's also vertex form. Joanna, what form is the last one? Standard form, good. Okay, so for all of these, whether I'm asking for the zeros, the roots, the solutions, the x-intercepts, I'm still looking to see where does it cross the x-axis. So I'm going to graph these on Desmos. The first one I already have graphed. So I can see where it crosses the x-axis, but to know for sure what point that is, you can click on it. Negative 1.50 and 10. So my zeros are negative 1.5 and 1. Okay, next one, need to graph it. X plus 1 squared minus 4. Okay, this one, when you click on the x-intercepts, you get negative 3 and positive 1. The next one does not have such nice answers, but it still gives you answers. So actually, let's just change it here. It was x, oh, there's a negative in front, and then it was x minus 3 and plus 5. Okay, so for this one, when you click this, you get 0.764 and 5.236. 0.764 and 5.236. And then what happened with the last one? The last one was different because why? It didn't touch the x-axis. Good, let's look at it just to make sure. But I believe that Destiny is right. So it's x squared plus 4x plus 7. X squared plus 4x plus 7. So it does not cross the x-axis. So if I was asking for solutions, I would say no real solutions, but what I'm asking for is x-intercepts. So it has no x-intercepts. Don't just leave it blank, you actually have to answer it. Okay? So when I see your notes are complete, I can give you your exit ticket. After the exit ticket, we need to finish up some math space assignments that have been waiting for you for a while. A couple people are done, but most of you have some more to do there.